All right, I want to go ahead and take a look at Lesson 11.3, Area of Circles and Sectors of Circles. Now, the area of a circle is the product of pi and the radius squared. So, A is equal to pi r squared. That's how you find the area of the circle. Remember, r is the radius. So you take the radius, you square that, and then you multiply that by pi, or you're going to leave it in terms of pi. Example 1. An archery target has a radius of 12 inches. What is the area of the target in terms of pi and to the nearest square inches? So your answer or answers should be, both there. I'm going to go ahead and draw a picture. Here's my circle. The radius is 12 inches, and we're going to be using that formula that I showed you above. A equals pi r squared. So A is equal to pi times 12, the quantity squared. Therefore, A is equal to pi times 144, or 144 pi. And it's super important that you include the units. Since we are in area land, our answer should be A equals 144 pi inches squared. And then I'm going to take this. So I'm going to do 144. So I'm going to do 144 times pi on my calculator. And you're going to use the pi symbol for this one. And you press the second caret sign so you can get that pi symbol there. So when you do 144 times the actual pi, you should get approximately 452 inches squared, because we're being asked to round to the nearest square inch. That's basically saying round to the nearest whole number. So that's example 1A. Let's take a look at example 1B. What is the area of a circular putting green with a diameter of 20 feet in terms of pi and to the nearest square foot? So we have our circle. The diameter is 20 feet, but I only want the radius. So we're going to take the diameter and we're going to divide that by 2. So your radius is 10 feet. So then let's put it all together. A equals pi r squared. A equals pi times 10, the quantity squared. So A is equal to 100 pi square feet. Okay, so that's in terms of pi. Now what we're going to do is we're going to multiply the 100 and the pi. So 100 times pi. And that is approximately, since we're going to round to the nearest square foot, that, again, just like before, we're rounding to the nearest whole number here. It's approximately 314 square feet. Example 1C, what is the radius of a circle whose area is 81 pi square inches? So this problem here is asking us to find the radius. So we're going backwards on this one. Let's write the formula out. A equals pi r squared. And the area is actually given this time. The area is 81 pi. So replace the capital letter A with 81 pi, which is equal to pi r squared. So if I'm solving for this variable here, well, let's divide both sides by pi. So you should get 81 equals r squared. Now, r squared, just like, when you have a variable raised to the second power, what do you have to do on both sides to get the variable alone? Well, you're going to take the square root on both sides. So your radius is equal to 9. So the radius is equal to 9 inches, and that's your answer. D, what is the diameter of a circle whose area is 95 square centimeters? Okay, so you need to find, for this problem here, you need to find what the radius is. So find the radius and then multiply by 2. So let's write A equals pi r squared. The area is given, it's 95, which is equal to pi r squared. Divide both sides by pi. So then we have 95 over pi equals r squared. Now note, it says 95 square centimeters, not 95 pi square centimeters. So we are not going to cancel any pi's out here on the left side of the equation. So this is where we are right now. 95 over pi equals r squared. Just like what we did before, we need to take the square root on both sides to get r by itself. So when you take the square root, you're taking the square root of r squared, and you are taking the square root of this whole fraction here, the square root of 95 over pi. And what I'm going to do is, when I put this in my calculator, you're going to do this. You're going to take the square root of 95 divided by second caret sign, and there you go. Your radius should be approximately radius is approximately 5.5. Okay, so the radius is approximately 5.5, but that's not our answer though, because we're asked to find the diameter. So when you find the radius, you're going to multiply that by 2. So r is approximately 5.5. You multiply that by 2. D is approximately 11 centimeters. D for diameter. Okay, this one right here. Area of a sector of a circle. Now, the area of the sector A is equal to the arc measure divided by 360 times pi r squared. Now, pi r squared, that's the area of circle. Okay, A is equal to pi r squared. Here's my equation. It's A equals x over 360 times pi r squared. Now, this is very similar to arc length. And remember, with, arc length, just going to make a note somewhere. It was L, the length, is equal to x over 360 times 2 pi r. Okay? So when you were given a circle and you were asked to find the length, you're trying to figure out how big the length is of a circle. You are trying to figure out, how long the pizza crust was using this formula. Now, in this context, if I'm given, or if I'm being asked to find a section or a sector of a circle, in the context of pizza, you're actually trying to figure out how long the slice is, how big the slice is. Okay? Because, look, if I'm given 2 circles here, I have a small pizza and I have a big pizza over here, and we're talking about, slices. In terms of degrees, let's say that this here is 65 degrees and this here is also 65 degrees. We're talking about rotation in this case. So it doesn't really matter in terms of degrees, the size of the pizzas, right? They're both 65 degrees. But in terms of you know, the area, of course they're going to differ. You have a small pizza and you have a big pizza, and if I, you know, cut them out and have, you know, individual slices, yeah, I'm gonna have a small slice, and the other one should be a big slice. Okay, and to calculate those things, we use this formula. Again, it's a equals x over 360 times pi r squared. Let's take a look at example 2. It says, find the area of the shaded sector, leave your answer in terms of pi, and round to the nearest hundredths. So, we have this circle here. You're given the radius, so r is equal to 4, and you're given basically the central angle. Okay, so let me make a quick note. This right here is our central angle. In this case, that's 65, and this is 65 degrees. Okay, we're dealing with degrees. Everything here is out of 360 degrees. So it's 65 degrees out of the 360. For this problem, your central angle is 53 degrees out of 360. So your x is 53 degrees. So let's plug everything in. We have a equals x over 360. So a is equal to 53 over 360 times pi. Your r is 4, quantity squared. So a is equal to 53 over 360 times, well, 4 quantity squared is 16. Multiply that by pi. That's 16 pi. So then let's go ahead and, you know, change this so that your answer is in terms of pi. Let me get the calculator out. So you're going to do 53 divided by 360. Hit enter. Then you multiply that by 16. Don't multiply the pi. Don't factor in the pi. You have this decimal here, and you're going to convert that decimal into a fraction. Math, enter, enter. So your area is equal to 106 over 45 pi. But don't forget the units. It's feet squared. Now, let's say that you're asked to round to the nearest hundredth on this one. Well, what you're going to do is this. So ignore this answer. Ignore this answer. We're going to go back to this. So it would be 53 divided by 360. There's your decimal. And then you're going to multiply that by 16 pi this time. So second caret sign. And there you go. So the rounded answer, your area is approximately 7.40 feet squared. That's the other answer. All right. Now that I showed you the calculator, I'm going to just set it up and then provide you the answers. Okay? Okay, here we go. So for B, we're going to use that equation again. A equals, this is 148 over 360 times pi, 6 quantity squared. A is equal to 148 over 360 times 36 pi. So A equals 74 over 5 pi, or it's approximately 46.47 meters squared. Okay, so let's take a look at C. So this time I'm trying to figure out the area of this particular section of the circle. Notice that the central angle over here is 65 degrees. So this is not 65 degrees, but we know that a circle is out of 360, right? So if this is 65 degrees, then what is left over? So I'm going to do 360 minus 65, which is going to give me 295 degrees. So the area of the shaded region, in terms of degrees, it's 295. So the area is equal to 295 over 360 times pi 11, the quantity squared. So your area is equal to 295 over 360 times 121 pi. Now put this in your calculator. 295 divided by 360. Then multiply that by 121. So then math, enter. So your area is equal to 7,139 over 72 pi inches squared. So now that we have the exact answer, I'm going to give you the approximate answer. The area is approximately 311.34 inches squared. Okay, so this time you're going to be multiplying by pi. Let's take a look at example 3. A circular pizza has a diameter of 12 inches and is cut into 8 congruent slices. What is the area of one slice in terms of pi to the nearest hundredth? So we have a circular pizza, its diameter is 12 inches, and the pizza is cut into 8 congruent slices. I'm trying to figure out the area of one slice. If I'm trying to find the area of one slice, you're going to be applying sector area formula. So what is the central angle of this particular pizza? It's not given, but we know, again, it's a circular shape. It's cut into 8 congruent slices. So really, it's 360 divided by 8, which is 45 degrees. So this angle here is 45 degrees. And the radius is 6. So A equals x over 360 times pi r squared. The area is 45 over 360 times pi 6 quantity squared. So A equals 36 pi over 8, or 9 pi over 2 inches squared. So if you were to put this in the calculator, you should get the simplified answer already. So this is what you should see on your calculator. But if you want to approximate this, or if you want to round, A is approximately 14.14 inches squared. All right? So that's your answer. Example 4, what is the better deal between the slices of pizza shown from the meme? I'm going to let y'all try that out on your own, and then I will provide you the work on screen. Okay? So that's all from me for today. Try example 4 on your own, and then compare your answers to whatever appears on the screen.